Okay, this is actually take 2 of this one. Computer just shut off in the middle of the last one. It was great. It's a great day. This rainy Friday in July. Hope everybody is having fun during the summer. Oh, good. No, I don't. Quit that. Anyway, okay, so we've talked about budget constraints in some previous presentations. That showed us all the different combinations of goods that people could afford or could obtain. And then we looked at preferences and the difference curves, which show us sets of combinations of goods that make people equally happy or given the same amount of utility. And today we're going to combine those two to see how people actually choose what they want to consume. So here we have a budget constraint. The information on prices and income that lead to this budget constraint are right here on the screen. You can read them. Anyway, we get this budget constraint, and the question on here is, would we ever actually consume the bundle at point A? We've talked about this in previous presentations. The answer is no. There are many other bundles that this person could afford to get to that would make them better off. So, like, for example, a point right here, that gives you the same amount of good Y. You're still at 20, but you have more of good X, and by our assumption, more is better. So this point B would be better than A. So no. And as we talked about before, we're never actually going to end up consuming any of the points that are inside the budget constraint. We will always end up somewhere along the budget line. So the point that we're actually going to end up consuming will be somewhere along that line. And today we're going to look at how we actually figure out where along that line we're going to be. So this is where we're going to bring in some preferences to combine with this to see where along the budget line we end up. So the next graph is going to show a budget line and some difference curves on the same graph. So just as I was saying earlier, if we want to bring in preference, just show why we wouldn't end up at point A. There are a lot of other indifference curves that are higher than the indifference curve going through point A that are still attainable to this person. So, for example, the indifference curve that goes through bundle B might look something like this. That's higher than the blue indifference curve, so the person is better off. Remember, higher indifference curves mean better off. So the person could consume point B, which is on the budget line, so it's affordable, and that would be better than point A. Okay, so both bundles B and C, in this case, are on the budget line, and they're both better than A. The question is point B or point C better? So as you can see here, and the answer is that C is better, right? So this is the place where the green indifference curve goes through the budget line again. Point C is makes you better off. You can get to a higher indifference curve, just like that. But in fact, all of the points along the budget line in here, in between the place where the green indifference curve cuts through the budget line, are better bundles than point B. Even at point B, the person can still be better off by moving closer and closer. So in fact, anytime an indifference curve cuts through a budget constraint in 2 places, that's a non-optimal bundle of consumption, because you can always move to a point on the budget line in between those 2 points and get to a higher indifference curve. So like, this is a budget constraint and here's an indifference curve. Moving to any point along here will allow you to get to a higher indifference curve. So like, bloop. And in fact, you're not going to be on your best indifference curve until the indifference curve only touches the budget constraint at a single point, so at a point of tangency. So here we see that, yes, in fact, point B was better than point A, but point C is going to be the best. So point C right here, which represents, about the pen struggle is back. About 30 units of good X and 20 units of good Y. That is going to be the optimal bundle that this person can consume given the prices and their income at the time. They can't get to any other indifference curve. I'd love to be on this indifference curve. Unfortunately, I can't afford to get there. It's off the budget constraint. The green indifference curve here is the highest one that still touches the budget constraint. So this point right here, point C, is the place that I can afford, but that gets me on my highest indifference curve. All right. Okay, so the important thing to note, and this is going to be super important when we get to the next presentation about how to find optimal bundles algebraically, is that optimal bundles are always found at the point of tangency between the budget constraint and the indifference curve. So, and something that's going to be super important there is that mathematically, at a point of tangency between two functions, the rate of change of the two functions at that point of tangency are equal. So, at the point of tangency that we just saw on the graph earlier, the quote-unquote slope or rate of change in the indifference curve is equal to the slope of the budget constraint, and that we're going to use that that fact when we start doing this work algebraically in the next presentation. Okay, so here's a little question for you all to do on your own. Let's assume that the x-axis represents bread and the y-axis represents water. Oh, Lord. You can see my struggle with these. The stylus is going to be an ongoing battle. Okay, anyway, so there are 6 bundles that are potential consumption bundles that are on the graph here. For part A, I want you to put them in order of least preferred to best preferred. Part B asks you which of the bundles are attainable, which ones are not attainable, meaning which ones are feasible for you to even get to. And then part C asks you to find the bundle that represents the optimum mix of bread and water that will make you the happiest, but that you can also afford. So go ahead. Take a second to look at this, pause the video while you think about it, or I guess this eventually will be in play pause it, so maybe you'll have to put in your answer, and then the next slide will have the answers on it. Okay, here are the answers. If you need to, you can pause it, check your work. If you have any questions, bring them to class. All right, this one was a short one. Brace yourself for the next presentation. We're actually going to be doing a teensy bit of calculus and a bunch of algebra, so it'll be fun. Talk to you later.